Good morning, dear students. Hope you all fine. Before going to today's class, let me revise the last two classes topics. First, we have seen what is meant by a solution. A solution means it is a homogeneous mixture of two components, solute and solvent. The one which is present in major component is known as solvent, and the one which is present in minor component is known as solute. For example, if you take sugar solution, where we are taking sugar only in small quantity, hence it is known as solute, and the sugar is dissolved in large quantity of water, hence here water will acts as a solvent. So solution is a homogeneous mixture of two components, solute and solvent. Next, we have seen the types of solution based on the physical state of the solute and solvent. Solutions are broadly classified into 9 types. Then we have seen the example for each type. Next, we have seen what is meant by a standard solution. Standard solution is nothing but a solution of known concentration, which means a definite amount of solute is dissolved in a definite volume of solvent. That is called standard solution. So standard solution means we know the concentration of that particular solution, whether it is 1 normal or 0.1 normal solution, like that. Then we have seen the types of standard solution. First one is primary standard and second one is secondary standard. First, we are going to see what is meant by a primary standard. Primary standard, which means it must possess the following properties, like it should be highly stable, that is 99.98% purity, highly pure substance. Then it should not be hygroscopic and deliquescent. Okay. Then it should be easily soluble. It must be cheap. It must not be expensive. So then we have seen so many properties. So primary standard means it should be a pure substance. It should be easily soluble. Then it should not be expensive, like that. Then secondary standard. Secondary standard solutions are highly deliquescent and hygroscopic in nature. Hygroscopic is nothing but absorbing water moisture from the atmosphere, so that it can be changed into liquid state by absorbing water. Example for hygroscopic compound is sodium hydroxide. Okay. Then example for primary standard is sodium carbonate, sodium chloride, then oxalic acid, ferrous ammonium sulfate. All these are example for primary standard. So secondary standard examples are, best examples are sodium hydroxide and potassium permanganate. Then the concentration of the secondary standard are determined using the primary standard. Then we have seen what is meant by a titrant. Titrant is nothing or otherwise known as analyte, what we are taking in the burette, that is your burette solution. Titrate is nothing but the solution we are taking in the conical flask. That solution is used for titration. Then what is the indicator? Indicator is nothing but which indicates the completion of a reaction by a change in color. Then what is meant by a volumetric analysis? Volumetric analysis, which is used to estimate the amount of substance present in the given solution. You are provided, example, if you are provided with HCl solution, using that solution by volumetric analysis, we are going to estimate how much amount of HCl present in the given solution. Okay. So far we have seen these topics. Now we are entering into today's class. What is meant by a titration? Titration is nothing but the process of addition of standard solution from burette into the solution of unknown concentration taken in the conical flask is known as titration. This titration is also we have seen in the last class. So today we are going to see what are the types of titration which are used in volumetric analysis. There are 4 types of titrations we are using in volumetric analysis: acid base titration, redox titration, precipitation titration, and complexometric titration. This is the basic idea about the 4 types of titration. Acid base titration, which means in which an acid or a basic titrant reacts with an analyte that is a base or an acid. I am going to say in detail in each type. So complexometric titration means there is a formation of complex. Then precipitation titration, the analyte and the titrant reacts to form a precipitate. Then redox titration, it will undergo both oxidation and reduction simultaneously. Then one by one we are going to see one by one. First, acid base titration. Acid base titration is otherwise known as neutralization reaction. See, HCl is an example for acid, NaOH is example for base. This is acid and this is base. The acid and base undergoes neutralization to give H2O, water plus sodium chloride, NaCl. This reaction is known as neutralization reaction. Once the reaction gets neutralized, there is no more H plus ion and OH minus ion present in the solution, because the H plus ion reacts with hydroxide ion to form water. It involves acid base neutralization reaction in presence of water as a solvent. This reaction involves combination of hydrogen H plus and hydroxide ion to form water. So acid base titration is nothing but neutralization reaction. The acid undergoes neutralization with base to form salt plus water. Once the reaction gets complete, there is no more H plus or OH minus ion present in the solution. For this titration, we are doing 2 experiments in your volumetric analysis practical. One is estimation of HCl and another one is estimation of sodium hydroxide. Using indicator, phenolphthalein indicator. The phenolphthalein indicator is colorless in solution. If you add 1 drop of phenolphthalein indicator in acid, still it remains colorless. Then we are you are taking 20 ml of HCl in the conical flask, then add 2 drops of phenolphthalein indicator, still it is colorless. Then we are taking sodium hydroxide in the burette. When we are titrating the conical flask solution against sodium hydroxide which is taken in the burette, it undergoes neutralization. So once the reaction gets completed, it is indicated by a change in color by means appearance of pale pink color, which is the end point of the reaction. Okay, then vice versa for estimation of sodium hydroxide. If you take sodium hydroxide in a conical flask, then add 1 drop of phenolphthalein indicator, immediately it will give pink color. If it is titrated against HCl, if it is taken in the burette, then there is the end point indicates the color change from pink to colorless. Okay, so acid base titration is otherwise known as neutralization reaction. Here the acid and the base undergoes neutralization to give water, salt plus water, NaCl plus H2O. Once the reaction gets complete, there is no more H plus and OH minus ion present in the solution. In acid base titration, we are using so many indicators like phenolphthalein, methyl red, methyl orange, then thymol blue. These are few indicators that are used in acid base titration. Next, what is meant by a redox titration? Redox titration is nothing but, the word redox comes from two words, combining two words, REDOX. The first three letters stands for reduction and OX stands for oxidation. So redox titration is nothing but both reduction and oxidation takes place in a reaction simultaneously. ஒரே நேரத்தில் அந்த ரியாக்ஷனில் ஆக்சிடேஷனும் நடக்கும் reductionும் நடக்கும். That reaction is known as redox reaction. In the example for this type of titration is ferrous ammonium sulfate versus KMnO4. You are using in your practical estimation of ferrous ammonium sulfate. The FAS, there your burette solution is KMnO4 and your pipette solution is ferrous ammonium sulfate, FAS. In that, in FAS versus KMnO4, the Fe2 plus ion undergoes oxidation to give Fe3 plus. Oxidation is nothing but loss of electron, whereas reduction is nothing but gain of electron. It gains electron and undergoes reduction. Okay, here I have given you one example, KMnO4 versus potassium permanganate versus sodium thiosulfate, Na2S2O3, sodium thiosulfate. Okay, here the manganese undergoes reduction, manganese undergoes oxidation. Okay, so generally redox titration is nothing but both oxidation and reduction undergoes simultaneously. There is a transfer of electron. This reaction involves transfer of electrons among the reacting solutions are either oxidizing or reducing agent. Okay, we have to consider only 2 points. Both oxidation and reduction takes place simultaneously, and also there is a transfer of electron among the reacting solutions. Okay, then what is meant by a complexometric titration? This is example for reducing agent, sodium sulfide. Then KMnO4, which is the oxidizing agent. Okay, then complexometric titration. Complexometric titration, the word itself we have the answer. There is a formation of complex. Okay, in this type of titration, the titrate combines with the titrant to form complex salts. The titrate is nothing but your solution which is taken in the conical flask. Then titrant is the burette solution. Both combines together to form a complex. The complex may or may not be soluble. It may either soluble or insoluble. For example, see, copper sulfate reacts with ammonium hydroxide, it will form a inorganic complex. Then silver nitrate reacts with potassium cyanide to form potassium silver cyanide complex. Then potassium nitrate. This is the example for the complex potassium silver cyanide complex. The picture shows the potassium silver cyanide complex. Then in complexometric titration, we are using a metal ion indicator, EBT, areochrome black tea indicator. So in acid base titration, we are using phenolphthalein or methyl red or methyl orange as an indicator. In redox titration, we are not using any indicator. There the KMnO4, potassium permanganate itself will act as a indicator. So the KMnO4 is known as self indicator. But in complexometric titration, we are using the metal ion indicator. The example for metal ion indicator is EBT, areochrome black tea indicator. This complexometric titration is used to estimate the amount of oddness present in the given water. உங்களுக்கு கொடுத்துருக்கிற வாட்டரில் எவ்வளோ ஆட்னஸ் ப்ரெசண்ட் ஆயிருக்கு அப்படின்றத டிட்டர்மைன் பண்ணுறது தான் இந்த காம்ப்ளெக்ஸோமெட்ரிக் டைட்ரேஷன். ஓகே, ஸோ இந்த டைட்ரேஷன் வந்து பார்த்திங்கன்னா we are using areochrome black tea as a indicator. Then you are using, see here, next experiment, areochrome black tea is a dye which is used to find the used with magnesium and zinc 2 plus titration. We are taking EDTA, ethylene diamine tetraacetic acid, as a burette solution. Using this EDTA as a burette solution, we are estimate the amount of hardness in your given water using eriochrome black tea indicator. We are see here in the conical flask we are taking 20 ml of hard water. The hard water contains hardness. Either it may contain calcium or magnesium salt, like calcium sulfate, calcium chloride, magnesium carbonate, magnesium sulfate, like that. So the water contains either calcium or magnesium salt. We are taking that, pipetting out 20 ml of hard water, then we are adding 2 drops of EBT indicator, so that you will get a color like this. This is the color of eriochrome black tea indicator. Then we are titrating it against EDTA, which is taken in the burette, so that the end point is the change of color from wine red to steel blue. This is the end point of the titration. Okay, so the complexometric titration is used to estimate the amount of hardness. Okay, the hardness, how much amount of hardness present in either, how much amount of calcium present in the given water, or how much amount of magnesium present in the given water, using eriochrome black tea indicator. The end point of the titration is wine red to steel blue color. Then last, precipitation titration. Here also precipitation, there is a formation of precipitate. In a titration of this kind, cations and the anions combined together to form a precipitate, combined to form a compound of very low solubility. Thus a solid residue separates out. Solid, see here, there is a formation of precipitate. See here, white precipitate, here the red orange precipitate. Okay, so precipitation titration is, there is a formation of precipitate here. For example, see, silver nitrate AgNO3 reacts with NaCl to form this Ag plus and Cl minus. Ag plus is cation and Cl minus is anion. Okay, so Ag plus and Cl minus combine to form AgCl, white precipitate. See here, white precipitate. Similarly, barium 2 plus reacts with SO4 2 minus. Ba plus, barium 2 plus is the cation and SO4 2 minus is the anion. So barium 2 plus and SO4 2 minus combine to form a barium sulfate, white precipitate. This is another example for precipitation titration. The formation of precipitate is this. Okay, so today we have seen the different types of titration which are used in volumetric analysis. The 4 different types of titration are acid base titration, redox titration, precipitation titration, and complexometric titration. Acid base titration, which means neutralization reaction. The acid and the base neutralize to form salt plus water. Once the reaction gets complete, there is no more H plus or OH minus ion present in the solution. Then indicator used in acid base titration are phenolphthalein indicator, methyl red, methyl orange. Okay, then next, redox titration. Redox titration is nothing but both oxidation and reduction takes place simultaneously. Then there is a transfer of electrons. Then in redox titration we are not using any indicator, because KMNO4 will act as a self indicator. It will act as a oxidizing agent, and sodium sulfate will act as a reducing agent. Another one example for redox titration is FAS versus KMNO4. We are doing it in your practicals. Okay, then complexometric titration. There is a formation of complex. The first point, there is a formation of complex. The titrant and titrate combines to form a complex. That complex may be either soluble or may not be soluble, either soluble or insoluble. This titration is used to determine the hardness present in the given water using eriochrome black tea indicator. Okay, in complexometric titration, in EDTA experiment, there is a change of color from wine red to steel blue. It is the end point. So complexometric titration is used to estimate the amount of hardness present in the given solution. Then at last precipitation titration. Precipitation titration means the word itself, it says there is a formation of precipitate. The cation and the anion combine to form a compound. It is the precipitate. Ag plus reacts with the Cl minus to form silver chloride, white precipitate. Similarly, barium chloride and H2SO4. Barium 2 plus reacts with SO4 2 minus to form barium sulfate, white precipitate. Thus a solid residue separates out. See, the residue is nothing but precipitate which is separated out from the solution. Okay.